So what is then the mechanical energy of an object? So the mechanical energy is given by the sum of the kinetic energy of the object plus the potential energy. We already knew that the kinetic energy is due to the speed and it's given by half mv squared, the mass times v squared, while PE is about the gravitational potential energy. And if we also have a spring, then we have to put the elastic potential energy. Now, the gravitational potential energy is given by mgz, where z is the height and it can be positive or negative or zero according to the reference. And EPE is equal to half kx squared, where x is the variation of length of the spring. Now, this will be then the mechanical energy of a system at a certain position. Now, let's do a small application. So a 60 kilogram mass skater moves on ABC. It starts from its motion from A without initial velocity. So at the point A, the speed is equal to 0, and whereas the height is equal to 3.5 meter. And reach the point B, where its speed VB is equal to radical 70 meter per second. And it's contained, and if we notice here, B is on the reference, which means that we can write that the height of B is equal to 0. This plane BC is taken as reference for the gravitational potential energy, and we have G equal 10 meters per second square. So we have to calculate the mechanical energy of the system skater Earth at the point A and B. We have ME at the point A is equal to KE at the point A plus GPE at the point A. So which means it's equal to half MVA square plus MG height A. Now A is above the reference, so we can directly put it height. So it's half. The mass is equals to 60. And VA is 0, which means that this is all equal to 0 plus 60 multiplied by 10 multiplied by 3.5. So the answer will be 2,100 joules. Now we'll do at the point B. So it's also KE at the point B plus GPE at the point B. Now we have here the height of B is 0, which means all of this part will become equal to 0. So since it's on reference, on the reference. Now we continue here. So it's half mVB square, which will be half. The mass is 60 and radical 70 square. So it's radical 70 all square, which will give us also 2,100 joules. Now we notice that we have the same answer. This will talk about it in the next video. Now, apply number 2, which ball system has the most energy? In order to know which one has the most energy, we cannot just look at the figure and just say that the first ball or the second ball at this position, at the initial position, which one has the most. In order to know it, we have to calculate the mechanical energy of each of the balls. So this is why we find ME of the first one at its initial position. So it's equal to KE plus GPE, which will be equal half mV1 square plus mgz1, knowing that here it's the reference. So we have both are above the reference, so the height is positive. And then we can directly put the values. So here it's 25 square plus the mass, it's 2 multiplied by 10 multiplied by 18. So we'll get here as answer 985 joules. Let's do now the second one. So ME2 is equal to KE2 plus GPE2 كمان equal half MV2 square plus MGZ2. كمان بنلاحظ إنه object is above the reference. So this means the height is also positive. So we continue the answer. So it's half. The mass is 2 multiplied by 20 square. Also, it's 2 times 10, and the height is 23. So we'll get here as answer 860 joule. هلا بعد ما جبنا values of the ME of each of the two balls at the initial position, now we can compare. So we can say now, since ME1 is bigger than ME2, this means that the ball 1, okay, has the most energy.